Hello everyone. This video demonstrates series production of 50 pull gears via the metal fused filament fabrication 3D printing principle using CMG Tech-X stainless steel filament, in this case 316L stainless steel. There are also other CMG Tech-X metal filaments available, including 174pH stainless steel, copper, H13 tool steel, and Inconel 625 super alloy. Like every sinter-based 3D printing technology, after printing the 50 pull gears with CMG Tech-X stainless steel filament, the printed parts have to go through the binding and sintering steps to generate the final printed and sintered parts. As mentioned before, metal parts which are printed via the metal fused filament fabrication 3D printing principle or any other sinter-based 3D printing principle need to go through a debinding step to remove some of the polymeric binder components. With the case of metal parts printed with CMG Tech-X stainless steel, so in the case of these 50 parts, they have to go through a debinding step in acetone at around 40 to 42 degrees to remove the acetone dissolvable binder component in order to generate a network structure for sintering. The 50 pull gears, which were debound in acetone for about 12 hours, have now been sintered at 1300 degrees C to obtain pure 316L stainless steel pull gears. Further post-processing can be carried out on the pull gears, such as tumble polishing, magnetic polishing, and bead blasting. The whole process from printing of the pull gears to the final sintered parts takes about 5 days. Thank you very much for watching this video, and I look forward to your comments.